In this section, we're going to look at rational functions where we either have a common factor in the numerator and denominator, or the degree of the numerator is larger than the degree of the denominator. We're going to jump right into the steps that we can follow to graph rational functions. This is a general process that will work for any rational function. The first thing you're going to do is you're going to reduce the fraction. And as you're reducing the fraction, you need to pay attention to any factors that disappear completely from the denominator. And those will give you what we call holes in the graph. Okay, and we're going to see an example of that. So I'm not going to go through the details of that here. Then we'll do all of our intercepts, x and y intercepts. And then we'll do our asymptotes. For our slant asymptotes, these occur only when the degree of the numerator is one more than the degree of the denominator. And to find that asymptote, we do long division, polynomial long division, and the quotient is the equation of the line, the slant asymptote. Then we plot everything that we have and we connect it all. So let's go ahead and just do an example. We have here the function f of x equals x plus 3 over x squared minus 9. We will start by reducing this. That means that we want to factor completely our denominator. This is a difference of squares. That's x squared minus 3 squared. So this factors as x minus 3 times x plus 3. And now we have a common factor of x plus 3. And so we can cancel it out, and we are left with just 1 over x minus 3. Now this is where, because the x plus 3 disappeared from our denominator, that means we have a hole when that is equal to 0. Okay, so we have a hole at x equals, and x plus 3 is 0 when x is negative 3. X equals negative 3. And the y coordinate we get by simply plugging that x value into this reduced form. So 1 over negative 3 minus 3 is negative 1/6. So this is the location of a hole in our graph. Next, we can find our intercepts. So for our x-intercepts, these come by simply setting the numerator of our reduced fraction equal to 0. Well, if you try and set 1 equal to 0, obviously this is never true. Okay, never. Therefore, that means that we don't have any x-intercepts. For y-intercepts, there can only be one. For the y-intercept, you plug 0 into the function, and you can plug it into the original or into the reduced as long as it's in the domain. So plugging in f of 0, if I plug it into the reduced form, I get 1 over negative 3. Okay, so my y-intercept is at negative 1/3. Then we're ready to find our asymptotes. So we'll start with our vertical asymptote. The vertical asymptote we get by looking at the denominator of our reduced fraction and setting it equal to 0. So x minus 3 equals 0. And solve for x, we get x equals 3. So x equals 3 is the equation of our vertical asymptote. For the horizontal asymptote, we look at our reduced fraction and we compare the degree of the numerator to the degree of the denominator. The degree of the numerator here is smaller than the degree of the denominator. And when that's the case, we have y equals 0 as our horizontal asymptote. Okay. We don't have a slant asymptote. There's none, because the only time we get a slant asymptote is if the numerator has a degree of 1 more than the degree of the denominator. So since our degree of the denominator is 1, the numerator would have to have degree 2 in order to have a slant asymptote. Okay, now we're ready to graph everything that we have. So we'll go ahead and plot our axes. We'll start with any points that we know. Okay, we know we have a hole. I'll go ahead and mark that. 1, 2, 3, negative 3, and negative 1/6. It's going to be right around there. And we draw a hole just like a little empty point. we have our y-intercept of negative 1/3. That's right around there. Okay. We don't have any x-intercepts. We have a vertical asymptote at x equals 3. So we go over to 1, 2, and 3, and we will plot that. Asymptote. And then we have a horizontal asymptote of y equals 0. That's here on the axis. And now we are ready to start drawing. We know we need to follow our horizontal asymptote, and we need to go through this hole and this point. So we're going to have to follow it like this and come down. And we can't cross the x-axis because we don't have any x-intercepts. So we can't turn around and go up. So we have to just come down and follow the vertical asymptote going downward. Okay, now as I jump over this asymptote, I need to know what the behavior of the function is. Is it the same on the right, or is it different? So that comes back to this factor of x minus 3 that gave me that vertical asymptote. Okay, that had an exponent of 1. Okay, so I can kind of think of that 0 of the denominator as having a multiplicity of 1. And an odd multiplicity means that the behavior is different on either side. So on the left side of this asymptote, we went down. That means on the right side, we go up. All right, and then we need to follow our horizontal asymptote. And of course, we're not allowed to cross the x-axis. So there's a sketch of this rational function.